So, this is the note section where I am recording myself and I am putting it up on the projector. Anything I do that looks like this will be recorded so you can go back and watch it later if you need help or if you miss a day where I am giving a lecture.
How's it getting recorded?
So if you'll think back to when we first started this unit, the very first thing I did was I put A, B, C, D up on the corners, and you had to walk to whichever category you fit into.
You do that again?
No.
When did we do that?
When you work.
Whenever you told us to.
The day we did it? He said it.
I don't even know what he said.
Just so you know, these are your notes. I mean, if y'all want your notes to be this disconjointed, that's fine. It doesn't matter to me. These are your notes.
Alfalfa.
You go back and listen and nothing makes sense because all y'all are just having your own conversations. That's fine. It's your conversations. Your class. So we walked to the corners. There were some questions that I asked. In particular, I remember asking where you were born. What was unique about that question?
You gotta just say if you were born in Fort Payne, if you were born in Alabama, and if you were born in the United States.
Mm-hmm.
If you were born outside of the United States.
Mm-hmm. So you as an individual might have fit into multiple categories. Right? If you were born in Fort Payne, you could have also fit into Alabama and U.S. So it wasn't easy to put you in just one category. Similarly, I asked a question about what color you were wearing. All right? You may have not been wearing any of the colors, so you may not have fit into any of the categories. Or when I did the birth months, did I do the birth months in here?
Yeah.
I just gave 4 choices, right? There's probably some of you that didn't fit into one of those categories. So what we were getting ready for and practicing for was the idea of a function. And so that's what we're fixing to define now and talk about is a function. You were the input, and where you went and stood was the output. That was where you fit in. In order to be a function, every input can only have one output. So while you might have fit into Fort Payne, Alabama, and USA, you could only stand in one at a time. Right? If you went to all of them, then you would no longer be a function. So let's talk about what a function is. So they give a formal definition here. They say a function relates each element of a set with exactly one element of another set. All right? I don't really use that wording, but it's still the same idea. So for me, if I had to define a function, this is how I would do it. A function is a special relation where each input has exactly one output. So again, a function is a special relation where each input has exactly one output. Now there's one word in that definition that you may not know a definition to either. Is there any of those words that you look at and you think, I don't know what that means? Do y'all know what a relation is in math? Okay. So I get you're trying to use context, relation, relationship, and that's kind of in the right ballpark. What we define a relation to be is just any set of ordered pairs. That's a relation. So what are ordered pairs again? You guys should know that. They're coordinates. They're an X and a Y. So the X and the Y have a relationship to each other. That's why it's called a relation. Right? Because they are paired together. And any set of a group of ordered pairs is called a relation. Now in math, and especially in algebra, we assign different variables for the input and output. Almost always, the X is the input, and the Y is the output. So we have every input X has exactly one output Y. So if I'm an X, I can only be paired with one Y. If I as an X go to more than one Y, I am no longer a function. Why U as an input couldn't go stand under multiple letters, because then it would have no longer been a function. All right, so this is kind of abstract, kind of hard to wrap your head around, but I want you to think for a minute. Can you think of any examples in the real world where we use functions? Where an input always results in exactly one output that's always the same. Shoe design. Tell me what you mean by shoe design.
Like, you take like a design of a shoe, put every
Teachers, any 7th and 8th grader who has
every
not been to
material
the library
together,
to get their picture
and it
made
always
may
comes
go
out
at
and
this
says
time.
shoe.
Any 7th grader and 8th grader that has not had their picture made, go to the high school library at this time. Thank you.
Okay. Mike could get there. You might could get there using that. That's kind of hard to. That would be a lot of different inputs coming together at once, right, to try to make a shoe. So I'd rather, we might could go that way, but let's talk about that one later. That one might be more challenging. Sun setting and sun coming back up. Okay. It's regular. It has a routine, right? My argument for that would be, what time's the sunset today?
You never know.
Yeah, you do. You can look up when the sunset is 10 years from now. It's mapped out. The meteorologist tells you every day when the sunset is.
About 8 o'clock, my bad.
I don't know. Say it's 8. Is it the sun going to set at 8 tomorrow?
Might set like 8 or 3.
Y'all don't know how sunsets work? Ah, okay, so let's talk about this. That's good. That's a good side topic. Maybe we'll learn about sunsets. Do you guys know what day the sun's out the longest?
June, it's the end of June. It's like June 28th or something.
It's close.
June 27th, June 26th, June 29th.
June 22nd and June 23rd is when the sun is out the longest. It's called the summer solstice.
Yeah. How long is it? I heard about this.
I don't know. The longest from whatever it's going to be in the year is on June 22nd and June 23rd. All right, so then what has to happen? If the sunset is the longest on this day, then what has to happen after it? It has to start getting shorter. And so the sunset gets shorter, the sunlight gets shorter and shorter and shorter until we get to the shortest day of the year, which is
January, December, November. December? Oh,
December 22nd and 23rd. This is where the sunlight is out for the shortest amount of time. And so then what happens after that? Then the sun starts being out longer and longer. Every day adds like a minute. Add a minute, 2 minutes, a minute, 2 minutes. It kind of varies. And then you finally get back to the longest day, shortest day. So right now, if the sun set at 8 today, what time is it going to set tomorrow? 7:59, 7:58. It's going to get shorter, 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 shorter until
You get to that shoulder day.
we get to the shortest day, where the sun's going to set at like 4:45. It's crazy how quick it gets dark in the winter. Okay, that's interesting. Let me give you my example of a function. Because as a human, we like things that are the same all the time, that are reliable, that we don't have to worry about, is it going to work or not? What happens when you get something that's unreliable?
I am mad. You get really angry and upset.
Or you replace it. Right? Just like you at your job. If you don't show up, if you're not reliable, if you don't do all your work here at school, unfortunately, I can't replace you. But your employer can. And that's not long. That's not far away for you guys. Not far away. Also, what about that special someone? What if they're unreliable? They're no longer that special someone. Okay. The thing that I always look to as can make me the maddest, that should be reliable, that every time I put an input, I want the same output, is a vending machine. Don't we love vending machines?
They're not reliable.
They are not reliable. I have to punch them.
Okay, so let's ignore the money side of a vending machine. Just pretend like that doesn't exist, because that can really muddy this discussion up. But let's pretend like we just had vending machines around that were free. Okay, and every time I went up to a vending machine and I pressed this button, what do I get as an output? I would learn.
Checks me.
Well, for me, I always like a nice Coca-Cola. Okay, so if I press that button and it gives me a Coca-Cola, I like that. It's very reliable. And I go press that button again, and I get a Coke. And I press that button, and I get a Coke.
Checks mixes.
What would happen if one day I press that button
And you get a Pepsi. Ooh.
I would sue.
or a water or Dr. Pepper?
Oh, baby.
Is my relationship with this button going to be the same?
No.
No, because it's not doing the thing that it's supposed to do. It's supposed to be reliable. It's supposed to, every time I input by pressing this button, I expect the same output, which is a Coca-Cola.
What if it gets stuck?
Well, that's the vending machine's fault. So let's think about it from that scenario. If I press the first button and I get a Coke, and every time I press the first button I get a Coke, this is a function, because this is the input. This is my X. Every input gives me the same output. I get one output every time. But what if sometimes I press the first button and I get a Coke, sometimes I press the first button and I get water? This input, is that the same input? It's the same input. I'm pressing the same button, but I'm getting different outputs. This is not a function. It's still a relation, because it's a set of ordered pairs, but it is not a function. Okay? Let's do a different example with my vending machine. Let's say that the first button works great, and every time I press it, I get a Coke. But let's say one day I just ventured out and I decided to press the red button. So now I press the second button. And when I pressed it,
Sun-kissed.
it was also a Coke.
Oh,
Wait, this? What?
and I keep testing the second button, and every time I press the second button, it also gives me a code. Is this a function?
No. Maybe, maybe, yeah.
What's repeated?
Output.
The output's repeated. But every time I press first, I get Coke. Every time I press second, I get Coke. Is it reliable? Does it do the same thing?
Yeah.
Yes, every time. This is also a function because this input always gives this output, and this input always gives this output. So your Y's can be repeated. Your outputs can be repeated, and that is fine. But your inputs have to always be tied to the same output. Right? And we'll look at some more concrete examples. But in my head, that's the best real example of how a vending machine works. It says each element means that every element in X is related to some element in Y. So if I go back to my vending machine, if the vending machine had 8 buttons, that means all 8 buttons have to work. If I press a button and it doesn't work, then that means I have an input that isn't mapped to an output. So it can't be a function. Every input has to have an output. The second one means exactly one, means a function is single value. It will not give back 2 or more results for the same input. So this is a very mathy drawing. Very much a mathy drawing. This is the set of all inputs, X. This is the set of all outputs, Y. Look at this input. Does this input have an output?
Yeah.
Yes. Does it have only one output?
Yeah.
Yes. This input, does it have an output?
Yeah.
Does it have only one output?
Yes.
This input has exactly one output. This input has exactly
Yeah.
one output. This input has exactly
They
one
have one
output.
output, they have the same output.
They have the same output,
It's okay.
but that's okay. As long as this input goes to only one output. These 2 buttons both give me the same thing. But it's still a function. It's still reliable. Is every input accounted for?
Yes.
Do you see anything that's not used?
But it's not
Is every output accounted for?
No.
Does that matter?
No.
No. We just need every input to work. You have a vending machine that didn't have cherry Powerade in it. That's an output that could possibly be in there, but it wasn't. That's okay. Just as long as the button is tied to something. So this is a relation, and this relation would be a function. Now look at some of these examples.
That's a no-no. That's a big.
Here's an input that maps to 2 outputs.
Nuh-uh.
That's not a function.
No, sorry.
Not a function. Because there's one that goes to many. That's the way they word it. Not a function. But this would be okay, right? We just talked about the differences. Okay, I'm going to work the first one. We've got a relation. What's a relation? A set of ordered pairs. We can represent this set of ordered pairs 3 different ways. As a table, as a graph, and as a mapping is what I call that last one. So yeah, let's do that. The first ordered pair was at 2, 3. So in my table, I would write 2, 3. Rocket science. Next is 4, 7. I would write the ordered pair 4, 7 in my table. 6, 8. I'd write the ordered pair 6, 8. Any questions here about moving it from an ordered pair to a table? Now the next one, graphing review. Right here is my origin. If I have to graph 2, 3, what's the 2 tell me to do? go to the right. The first number, my x, tells me to go left or right. If it's positive, I go right. If it's negative, left. So I'm going to go right 2, which puts me here. And then the 3, which is the y, tells me to go up. Positive goes up, negative goes down. So I'm up 1, 2, 3. And so right here is my point. 2, 3. Next is 4, 7. So we go back to the origin. 4 means I go right 4. 7 is up 7. 1, 2, 3, 4, 5, 6, 7. And I plot my point. Oh no. And I plot my point. Oh no. Thanks.
What's the math word?
Then the last one is 6, 8, which means I go right 6, up 8, which would be right here. Any questions there about the graph? Where those points go? The last one is a mapping. So in a mapping, I only write each value one time. So for instance, here I have an x, here I have my y's. If I have an x that occurs more than once, I only write it once. If I have a y that occurs more than once, I only write it once. In this case, they're all different. So my x's are 2, 4, and 6. Again, I would always put those in order from least to greatest. And same with y's. 3, 7, and 8. In order, or just put them in order from least to greatest. And then we draw lines from each input to its output. So 2 is supposed to map where? 2 maps to 3. So we connect 2 to 3. 4 maps to 7, and 6 maps to 8. Any questions about anything I've done here?